Okay. So first of all, we're going to start with these quadratic equations, which is section 3.1. And this one, these first few that you're going to talk about graphing, is a lot like the way you graph that bonus problem, or if you tried to graph the bonus problem. But for quadratic equations, they can be written two ways. It could be written as f of x is equal to ax squared plus bx plus c. And this is actually the form that that we use the most, that I like to use the most. Or it could be written as f of x is equal to a times x minus h squared plus k. And this is one where we can do what we did on that bonus, where we can think about the shifting. It'll be the same way as that absolute value was on that bonus on that test. But most of the time, quadratic equations are written this way because you have to factor them. You get your x-intercept and all these sorts of things. But we're going to talk about both of them. On both of these, what's your highest exponent? 2. So it's a quadratic. And what kind of shape is a quadratic graph? One of those basic ones that was on your last test. Right, it's the U shape. So this graph is a U shape, which we talked about before, we call a parabola. Okay? So it's your basic graph that we had on this last test is f of x equal x squared. That was the basic graph. And this is what we're going to do. We're going to deal with this U shape, but we're going to graph them when here all these A, B's, and C's are different numbers, and so forth. One thing that we didn't talk about, and I always talk about, this point down here at the origin, that was the main point when we got ready to start doing that shifting on that last test. But this point down here, where it changes from going from decreasing to increasing, is actually called the vertex of this parabola. And do you agree that a parabola is symmetric? And symmetric means it looks the same on both sides. If you had a mirror, and we're going to say our mirror is our y-axis here. If that little dotted line was a mirror, this graph looks exactly the same on both sides of it. Do you agree? So we call this line that goes through the vertex is called the axis of symmetry. Yeah, and in this case, it would be the line, it's a vertical line, and it's x equals 0. That's your y-axis. And of course, you see, how would you say this graph opened, up or down? Is our U going up, or is our U facing down? You would say that this opens up. And of course, you know the domain of, what's the domain of any quadratic function? Right, all real numbers, negative infinity to positive infinity. And for this particular one, which is my range, and your range is going to change based on where your vertex is. But for this one, what's my bottom y value here? 0, and it goes all the way up. So my range is from 0 to infinity. Now that's our basic graph. This is something we've already learned. The only new things you have is the terminology of the vertex, which is that point at the bottom. Of course, this will be the minimum point on this graph. And then the line that goes through the vertex is called the axis of symmetry. Those are the only two things that are extra. Now, you could also have a quadratic function that opens down. If you have a negative in front of your x squared term, that means your u will open downward. That would be the graph of this one. That negative in front means that it flips your graph over the x-axis. Or reflects it, it's another terminology. We'll just say it flips it. So you would say that this one opens down. And then of course the vertex is still here. This is where it changes from going from increasing to decreasing. Our vertex is on this particular graph would be the maximum point, right? And the vertex, the highest point on this graph. And your axis of symmetry is the same thing. Your x equals 0. Axis of symmetry will always be a vertical line. So it'll always be x equals. So my domain is all real numbers. Your domain will always be all real numbers. This is one on this next test you shouldn't miss because the only answer for the domain of a quadratic equation is all real numbers. But what's my range on this one? It's going all the way down, and then it comes up to what? Comes up to 0. So my range is from negative infinity to 0. 0 is a point is included, so you put a bracket. Now notice one thing here. Your range is always going to have the y value from the vertex in it. Because this is the minimum point here, so your range started out with that one. The vertex here is the maximum point, so your graph, your range ended up with that y value from the vertex. And that'll always be the case. And I'm going to write all that down again in a little bit. But these are your basic two graphs. Okay? First of all, we're going to knock this form out of the way since we kind of already know a little bit about how to use it. So let's look at this second form here. When your quadratic equation is written in this form, okay, we're going to talk about some different properties. One thing about it when it's in this form is remember that completing the square stuff we had to do on the circle in this last test to get it in center radius form? You actually, if your quadratic equation was in standard form, you could write it in this form by doing completing the square. Okay? But most people don't like to, that's kind of too many steps to the problem. So we're going to just talk about this form in general. First of all, you're going to be able to tell which way your graph opens is always based on the A. And this is going to be whichever form you're in. A tells you if it opens up or down. Just like on this one. It opens, if A is positive, it's going to open up. That means your U will look like this. If A is negative, your graph is going to open, it opens down. So that means your U will look more like that. That line that goes through the vertex. Before I write this on here, I'm going to leave it blank for a second, but I'm going to leave it in this order because on your test, I ask you for the axis of symmetry before I ask you vertex. Let's talk about the vertex. And I'm going to tell you just two different ways and see which way clicks with you the most. So right now, I just want you to listen. So I hadn't wrote anything over there yet. But let's say if I gave you y is equal to x minus 2 squared plus 3. Let's say if this was your bonus on that last test instead of being an absolute value problem. Well, you would say, well, this 2 is being subtracted on the inside of the function, right? Well, what would make that 0? Positive 2. Well, 3 is being added, so that means it will also go up 3. So this is what you would have done on that test, right? Well, what's the vertex? What's this point right here?
2, 3.
That's the point 2, 3, right? Well, let's look at what happened. Look back at this equation. What happened to the sign on that 2? It changed. It's the opposite, right? But the sign out here on the K part, it stayed the same. Just like it did on all those other ones we did. So we really already know how to do everything in this form. But to get the vertex, your formula for the vertex is the formula HK. But it's kind of like that deal was that center radius form of a circle. What do you notice right here in this formula? It has a negative. Now when you multiply something by a negative, it changes the sign. Take the opposite up. Just like with the circle, except here though, the H has a negative, but the K has a positive. And when you multiply something by a positive number, the sign stays the same, right? 2 times 5 is 10. 2 times negative 5 would be negative 10. It stays the same as when you graph. So when you multiply the sign on the K, you don't change like you do on the circle, but you have to change the sign on the H because it's got a minus sign in front of it in the formula. So when you do the vertex on the H, you're going to change the sign. But the K, you don't change the sign. But see, you're smarter than all this anyway because you already know from that last one which way it's going to shift. So you could shift it and graph it and figure it out probably faster than if you tried to memorize something extra. Right? And the vertex will always be x equal whatever the h value, whatever your x is in the vertex. The axis of symmetry always goes through the vertex. So the axis of symmetry would be x equal h. Alright, and then we're also going to find x and y intercepts. Your y-intercept, which is the easiest one. And what's the y-intercept? This is the point where the graph does what? Where your graph crosses the y-axis. So to find your y-intercept, you just have to put in a 0 for the x's, just like you did on your test. So the y-intercept will be f equals 0. So it'll be some point where your x's are 0, and then you'll have whatever it is when you plug 0 into the function. And that was going to be our easiest one. Your x-intercept, and notice I have an S on that one. On a quadratic equation, when you factor a quadratic equation, it's got an x squared. Remember I told you the highest exponent is how many answers you get? So most of the time, and your answers is your x-intercepts. We solve quadratic equation by setting it equal to 0 and factoring. Well, when you set it equal to 0, when y is 0, that's how you find x-intercepts. So for your x-intercepts, you're going to set your equation equal to 0, and you can solve by factoring, or if it's in this form, we'll solve by square root property. Okay, but you'll usually have 2 of these. This one y is 0. So this is when you set your function equal to 0. And doing this about this axis of symmetry to make sure you're with me there. You agree 0, 0. But if I put in 1, what's 1 squared? 1, so I got the point 1, 1. And if I put in 2, I would have up here the point 2 forward. You agree? But if I put in over here negative 1, what's negative 1 squared? 1. And if I put in here negative 2, what's negative 2 squared? 4. So when I say it's symmetric, that means on each side, these y values are exactly the same. I mean, it's like a mirror. Your x's are either going to be positive or negative because your graph's on both sides here. You got some in quadrant 1, quadrant 2. But no matter what number you put in here, you're going to have the same y values for both of them all the way up. Because like if you put in 3, 3 squared is 9. Negative 3 squared is 9. So you see your y's are exactly the same. That's what I mean by it's a mirror. It's exactly the same on both sides. Alright. But let's look here at, let's see if you're told to graph. In number 1, we want to graph f of x is equal to x minus 5 squared minus 4. And the way it's going to look on your test is it's going to have opens, it'll have a blank, it'll have axis of symmetry, x equal, and it'll have a blank, and then it'll have the vertex with a blank, and then you have y-intercept with a blank, and you'll have x-intercepts with a blank. And regardless of which form it's in, these are the blanks that you have. is understood to be 1 here. So how is this, is that positive or negative? Positive, so that means this U is going to open up. Okay? Axis of symmetry is x equal h. But remember, this is where you change the sign. So instead of it being negative 5, it will be x equal positive 5. My vertex is the x from the axis of symmetry, which is 5, and then it's the k. That's what's out here. What's over there? Negative 4. And that sign stays the same. Now my y-intercept is when I let x equal 0. So I need to evaluate f of 0. That's going to be 0 minus 5 squared minus 4. Or that's negative 5 squared minus 4, which would be 25 minus 4, or 21. So my y-intercept is the point 21. We're going to jump a little bit on this side. Now your x-intercept, that's what makes your function, that's when y is 0, or when f of x is 0. That's when x minus 5 squared minus 4 equals 0. Now you see you got a squared, so you're going to probably get 2 answers here. Now you got 2 options. You can pull this out, say x minus 5 times x minus 5, subtract the 4, then solve it by factoring. Or you could do square root property. Remember, square root property is when you have something squared equal to a number. So let's move that number over. That could be x minus 5 squared equals 4. Then what did you have to do to both sides? Square root property, you take the square root of both sides, and you couldn't forget that plus or minus. So that's when x minus 5 is equal to plus or minus 2. So that's when x minus 5 equals positive 2, and when x minus 5 is equal to negative 2. Add 5 to both sides. So one of my answers is when x is 8. Add 5 to both sides. So my other answer is when x is 3. So my x-intercepts are 8, 0, and 3, 0.
8 plus 5 is 7.
Say that again? 7? Sure is. There we go. So now we have all this information so we can graph it. But now you're already way smarter than, so you could have actually graphed it just by looking at it though, without knowing any of this stuff, right? But the thing that this is going to help you, it's going to help you know, you're going to know this part regardless. But now you actually know it's not just a rough sketch like what we did over there on that one. You actually know where it crosses the x-axis, and you know where it crosses the y-axis, which we're going to make a big jump here. Let's do here, x-intercept, is it? You've got an x-intercept at 3, and x-intercept at 7. What's my vertex over here? 5, negative 4. 1, 2, 3, 4, 5, negative 4. We also know my axis of symmetry is here at negative 5, positive 5. Alright, so look at what we've got so far. We know it's going to open up. My axis of symmetry is that dotted line that goes through it. That's x equal 5. My vertex is the point at the bottom, 5, negative 4. My x-intercepts are here at 3 and 7. And notice, they're symmetric. Look at the axis of symmetry. See this line right here? How many units to the right is this x-intercept? 2. How many units to the left is this one? 2. So that's what symmetric means. If you got a point on one side, you have to have that same point on the other one. And then way up here at 21, and we're going to stretch a little and say that's 21. That's going to be our other one, our y-intercept. Now on your test, I'm going to ask you for 5 points. How many points do you see up there right now?
4.
You see 4, right? You got your y-intercept, your 2 x's, and your vertex. But we're going to use what we know about symmetry to get our 5th point. How many spots over to the left is this y-intercept? 1, 2, 3, 4, 5. You agree that? Look at the axis of symmetry. To get to this point, that's 1, 2, 3, 4, 5 units to the left. So that means I've got to have the same point at 21 if I go 5 units to the right. So that would be 1, 2, 3, 4, 5, and I've got to have another point up here at 21. So then you would have your parabola. Now you like all that scooting around a lot better? And what I'm going to let you do on this test, I'm going to give you what I have here. And sometimes, and I'll decide closer to test, I don't actually, when it's in this form, ask you for x and y intercepts. So I will let you do the rough graph, scooting it around. Like here you'd say, okay, that's happening on the inside of the function, so that means it's going to move, what would make it 0, 5 to the right, minus 4, down 4. So you'd get this vertex point anyway. So you'd graph it, and then you can fill that blank in based on what you know. Then you can say, oh, well, my axis of symmetry is always the x of the vertex. It's positive, so it opens up. A lot of times when it's in this form, all I will ask you is, I'll give you this part right here, tell you how it opens, axis of symmetry, vertex, and I'll ask you to give me a rough sketch of the graph. But I do want you to know, to be able to see how you would get x and y intercepts. And your x-intercepts, that's the zeros of this function. That's what, if you set it equal to 0, what would make it? Remember we had that test on quadratic equations where you set it equal to 0 and you solve by square root property, all those sorts of things? So that's what we're doing there. Alright, now let's look at what's in the other form, because I like this other form better. And most of the time you see parabolas written in this standard form most of the time. Well, you know what? Before I do that, let me give you one example of this one to do on your own. So I'll give you number 2. Let's say if I want you to graph y is equal to x plus 2 squared plus 1. And I want to know, actually I want to see how smart you can be if I put a negative out there in front. Okay? I think you can still do it. give y'all plenty of time to write this. Have y'all done this one? Okay, so first of all, let's just do my little rough sketch. The 2 is being added on the inside of the function, so you ask yourself, what makes that 0? Negative 2. So we go to the left 2, and then this 1 on the outside means that it would go up 1, right? So you got your vertex. So you can come over here and say, okay, well, my vertex is at negative 2, 1. Or you can remember what I told you earlier. You change the sign on the x, but the y part stays the same. All right, well, my axis of symmetry is always the x of the vertex. How's this graph going to open, up or down? Down, because it's got a negative in front. So basically, all you've got to do now that you know that vertex, is you can just give me a rough sketch of that parabola going down.
And this is down that side over there.
Well, I don't know. This is a rough sketch. Now, that's why, if you really want to make sure, you can do that x-intercepts, and you know how far it went over. But, and you can do your x-intercept as well if you wanted to on that one. So we're good there. Alright. Now, this is when it's written in this other form. This looks like a whole lot more stuff, but you're going to see this is a whole lot easier when it's written in this form. So, same thing opens. If A is positive, the number in front of x squared, it opens up. If A is negative, it opens down. Axis of symmetry is negative b over 2a, where b is the coefficient in front of x, a is the coefficient in front of x squared. So the vertex is going to be whatever you get when you do negative b over 2a. You plug it back in of all your x's and get your y value. Your y-intercept is when x's are 0. If x is 0, both of those terms here would be 0, right? So you're just left with the constant term. X-intercept is solving quadratic equations, just like you did on a couple tests back. Set equal to 0, solve by factoring the quadratic formula.
Can you explain axis of symmetry and vertex? I was writing the other stuff down.
Okay, your axis of symmetry is always going to be x equal negative b over 2a, where b is going to be the coefficient in front of x, and a is the coefficient in front of x squared. When you just plug that in, that's just the formula. That's part of it. Out of all the stuff out here, that's really the only thing you're going to have to memorize on this next test is that negative b over 2a. That's your only formula. And once you get it, that will always be the x of the vertex, because that has to be the same. And then just like when you're filling in a t-chart or something, if you know an x value, if you want the y, you just plug it back into your function. So I just wrote that in function notation. That'll be easier when I do an example with actual numbers. Now, like I said, your y-intercept is when x is 0. Well, if x is 0, both of those terms will become 0, right? And 0 plus c is just c. So on this, you'll always understand by looking at your y-intercept, because it'll just be your constant number. X-intercept, which is the zeros of this function, which is what makes this function equal 0. So you set it equal to 0 and you'll factor it, or if it's non-factorable, you do quadratic formula. Domain, like I said before, is always all real numbers. Range, if it opens up, so if you have a parabola that opens up, do you agree that the vertex is the minimum point on that graph? So your range would be the y of the vertex all the way to infinity. And if your graph opens down, that means you're going to go from negative infinity, and then that vertex is the maximum point. So it'll go to the y of the vertex every single time, like what we talked about earlier. Then we'll sketch it. Now let me ask you this. When you're talking about graphing u's, every single parabola doesn't necessarily cross the x-axis. I mean, one of them, it could look like this, and if you had a parabola, let's just say this is my parabola. would look like that. And you'd say, okay, it's got two x-intercepts, right? And of course, on this case, the y-intercept would be the vertex. But I could have a parabola that actually had a vertex here and look like that. Does it have any x-intercepts? No, there's no x-intercepts on that. And what's going to happen right here, if there's no x-intercepts, it's not going to be able to be solved by factoring. It's going to mean that you get quadratic formula and that you get an I. It's got complex zeros. If it does not cross the x-axis, you had to do quadratic formula, and it's got an I in it. It's got a negative under that square root. So my zeros are complex. And complex zeros are not on the real number line, your x-axis. Okay? Also, you could have, if you have an irrational, it might not be factorable, but it could still have real zeros. Like if you have this, 2 plus the square root of 3. Well, that's just a decimal number. It's irrational, so it definitely keeps going and going. But it is something that you could actually plot. So the ones where it's not going to have x-intercepts is going to be where it has an I. Remember doing all those quadratic equations, we get to pull an I out because you got a negative under the square root? That's what's going to happen there. I'm kind of nice to you, and most of the ones I give you, you will be able to solve by factoring. But I do want you to know, if it's non-factorable and has an I in it, it will not have any x-intercepts. Alright, so now let's look at an example. Let's say if I tell you I want you to graph the first one, f of x is equal to x squared plus 6x plus 5. Somebody just run off with my blue markers.
There's a blue marker over here about the field.
Alright, so let's look at this problem and see what we can do. Now this is the way your problem's going to look on your test. Is you're going to have the function, I'm going to have all these blanks that you're going to fill in. So if I were you when you do your homework, I'd try to fill in and work it with this same template. Alright, how would you say this graph is going to open? Up or down? Up. The number in front of x squared is positive, so it opens up. That didn't work.
I'll do green for right.
So it opens up. Axis of symmetry is x equal negative b over 2a. Well, let's see, what is that? What's b in this problem? 6. That's negative 6 over 2, and a is 1, right? So what is negative 6 divided by 2? Negative 3. So my axis of symmetry is the line x equal negative 3. Is everybody okay there? Now my vertex is always the x from the axis of symmetry, so it's the negative 3. And then if you know the x, how do you find the y coordinate? How do you do it on a t-chart? You just put it in place of the x's, right? So I need to find f of negative 3. That means I need to find negative 3 squared plus 6 times negative 3 plus 5. You just put the negative 3 in place of all your x's, just like you did on a t-chart. Negative 3 squared would be positive 9. 6 times negative 3 is minus 18 plus 5. So that's what, negative 9 plus 5 gives me what, negative 4? So on the vertex, you use the x from the axis of symmetry And then you just plug that number back in place of the x's in your function, and it gives you the y part. Right good there.
So use the x from the axis of symmetry, put it back in the formula.
Right.
And then that's the answer.
Right.
For the vertex, the other side.
For the y value. Now my y-intercept is always found by letting x equal 0. Like I told you before, if these are 0, what's the only thing you're left with? The constant term, which is 5. So far, you already know these basic things about a graph, because they're the same with lines, except the only thing you didn't know was axis of symmetry and vertex. But if you know that negative b over 2a, you can get both of those, right? Your x-intercept is when your function equals 0. So this is going to be when x squared plus 6x plus 5 equals 0. The zeros of this function is solving this quadratic equation. So you ask yourself, I need to factor. There's no common factor. Factors into a binomial times a binomial. Factors of x squared is x times x. Last number is positive, so signs are the same as the middle. What factors of 5 when you add give you 6? 5 and 1. Well, x plus 5 is 0 when x is negative 5. X plus 1 is 0 when x is negative 1. So my x-intercepts are at negative 5, 0, and negative 1, 0. Now what did I just tell you the domain was for all of them? All real numbers. And we're going to look at it and then we'll tell you the range, even though you can get it and know what you do with vertex. So far, so good. Any question about any of these blanks? Alright, let's just graph it in order. It opens up, so I know the U is going to be going up. Axis of symmetry, that's that x equal negative 3, that vertical line right here. Alright, that's axis of symmetry. Next is my vertex. It's at negative 3, negative 4. Alright? So I plotted the two things that I know. I did it right in order. Axis of symmetry and the vertex. My y-intercept is at 5. I skipped up some pi here. My x-intercept is at negative 5. 1, 2, 3, 4, 5. And negative 1. So I've got everything plotted. I filled in every blank in order as they come in the problem. Now let's talk about how I'm going to do it. How many points did I tell you I'm going to be looking for on your graph? 5. Well, I've got my 4, and notice these are symmetric. These are both 2 units to the right and left of the axis of symmetry. How many units is this from the axis of symmetry? 1, 2, 3 to the right. So that means I've got to have another point at 5 at 3 to the left. At that same 5, right? If this point was 3 units to the right, I've got to have that same point 3 units to the left for it to be a mirror. And then you just want to connect the dots. Are we good there? Now let's look at range. What's my bottom y value here? Remember I told you it'd be the y, the vertex? So it's going to be from negative 4 to infinity. Range is bottom to top. Your bottom y value is negative 4 and it goes all the way up to infinity. Are we okay there? Alright, let's look at another. On this next one, let's say if I have f of x is equal to negative x squared minus 2x plus 8. We want to find everything here. 0.9 units each direction. Your Mountain Dew or something, keep you up to that. Alright, right now you shouldn't have any problems getting at least to the y-intercept line. You really shouldn't have any problem with any of them because you know how to get rid of that negative out front. But if you at least get to the y-intercept, then we'll start working it together. What, a negative 2 over 2 times negative 1. So that's positive 2 over negative 2, which gives you x equal negative 1. We okay there? So my vertex is the x from the axis of symmetry, the negative 1. Now let's plug it back in. Find f of negative 1. That's a negative 1 squared minus 2 times negative 1 plus 8. Let's be careful, make sure nobody missed it here. I'm going to word this two different ways. How many negative signs do you see right there? 3. There's 2 here, 1 out front. How many? But 3 negatives give you what? A negative. Because when you square a negative 1, it would make it positive. The negative out front makes it negative. Negative 2 times negative 1 would be positive 2 plus 8. 8 plus 2 is 10, minus 1 gives me 9. So my vertex is the point negative 1, 9. We okay on that? Yes? Ron? Okay. My y-intercept is when x is 0, but it always will be the constant term. So my y-intercept is the point 0, 8. Now x-intercept is what makes this function equal 0. So that's when negative x squared minus 2x plus 8 equals 0. Well, we never like to factor do anything with that negative out front, so what do I need to do? I can factor it out, and that gives me x squared plus 2x minus 8 equals 0. Now I can divide both sides by negative, and it's gone, right? Or you could have multiplied everything by negative 1, just changed all the signs. So far, so good. Now let's factor what we have here. What factors of 8, when you subtract, give you 2? 4 and 2, you want the 4 to be positive, the 2 negative? Well, x plus 4 equals 0 when x is negative 4. X minus 2 is 0 when x is 2. So my x-intercept is at negative 4, 0, and 2, 0. So far, so good. Any questions on how we fill in any of the blanks? Alright, then let's start graphing. Starting with our list. We know it's going to open down. Axis of symmetry is here at negative 1. Okay. Next, I'm going to graph my vertex, which is at negative 1, 9. There's my vertex, and I know this U is going to come down. But to make it more precise, just in a rough sketch, let's go through everything else. My y-intercept is at 0, 8. My x-intercept is at 2, 0, and negative 4, 0. 1, 2, 3, 4. So I've got my 4 points. Let's make sure, and also check your intercepts. Make sure they're symmetric. From the axis of symmetry, this is 1, 2, 3 to the right. This is 1, 2, 3 to the left, correct? So up here, this point is 0, 5. That's 1 point to the right. Do you agree? 1 unit to the right. So 1 to the left, I'd have to have another point up there at 8. So it looks like a mirror. Now you want to connect them. And you've got your quadratic equation. Everybody found the graph. Now my range goes all the way to the bottom, so that's negative infinity up to 9. And notice that will always be the y, the vertex. Alright, any problems doing one that goes up and one that turns down? We did it both ways it could be written. These take a lot of practice, but like I said, on these I will always ask you everything. Okay? And like I said, I'm pretty nice. I'll make sure yours factors. But if you happen to have one on homework, and I don't think I picked the homework one that didn't. Normally I do, but I threw it out. But if you end up seeing one anywhere, my math lab, and it doesn't factor, that means you do quadratic formula. And if it has an I, that means there's no x-intercepts. Alright, are we good there? Now we're going to talk just a little bit about section 3.2, the synthetic division. And to be honest with you, this stuff right here, I don't know, I guess I could have put it on that last test, but it had so much stuff on it that I didn't. But everything else we're going to do is, for the rest of this chapter 3, is nothing like this. This sets out on its own. This is like the first page of your test, and everything else is going to be completely different. Okay, we're not going to be graphing anything else on this test except for these parameters. Everything else is going to be factoring, finding all the zeros, which is the x-intercepts, of higher order polynomial functions. Alright. So let's look at 3.2. Synthetic division. And you're going to like this. Synthetic division. Well, first of all, we have what's called the division algorithm. And I really don't care if you write this part down or not. What you're told that if you're given any function quotient f of x, the division algorithm says you can break it down. It'll be equal to g of x times q of x plus r of x. Now this is something you've known since 3rd or 4th grade. Okay? So, and I want you to I'm going to tell you what each one of these are, but I'm going to tell you what the division algorithm. This is the way you check a division problem. So if I had, say, 8, and I'm dividing it into 127, what do you do? 3rd grade, how would you do this problem?
8 goes into 12.
One time, 8. Right here you're subtracting, you get 47. How many times will 8 go into 47? Well, it won't go full 6, will it? 5. And you'd say 45 and get a remainder of 2. Okay, this is the division algorithm. How do you check this problem to know if you got it right? You take the answer, which is called our quotient, times the divisor, what you were dividing by. 8 times 5 is 40, carry the 4. 8 times 1 is 8, plus 4 is 12, and then you add that remainder. Oh, what did I say? 8 times 5 is not 45, it's 40. Remainder of 7. Y'all got, stay with me. And then your answer should be what you had underneath, right? That's the division algorithm. What happens is here, g of x will always be a lower degree polynomial. Q of x, this is your answer. This is your quotient. I like your answer. R of x is your remainder. Okay? So Q of x is what you were dividing by. Quotient is the answer, what you got, and your remainder. Okay? So this is what you were, like in this case, this would be the 8. This is the 15. That's the 7. Right? Alright, now let me show you about this synthetic division. Listen, the only time we're going to come back and talk about that division algorithm, it just says that anytime you're given a function, anytime you're given a higher order polynomial, it can always be broken down into its factors, which we're going to say our factors are going to come into play in here too. But for synthetic division, we use this to divide polynomials. Divide polynomials. You'll be given some function, f of x, divided by x minus k. And f of x, it could be x squared plus 3x minus 5. It could be x to the 5th. It's some big long polynomial. But f of x is some polynomial, and you're dividing it by a factor. Okay? The way you're going to set it up is the first thing you're going to ask yourself is what makes this 0? What makes the denominator 0? What number, if I put in place of x, would make that 0? K, right? Positive k will be the opposite of what you have. So when you do synthetic division, you're going, whatever makes that denominator 0, you put it over here. You're going to draw this little box thing. Now, I'm old-fashioned. I do it the way I learned it. My box dropped down. I think my math lab, someone might show your box going up. I think this way's easy. Okay. And right here, you're going to put coefficients of f of x. And you'll fill in missing terms with a 0. So, for instance, if you had an x cubed, and if you didn't have an x, it goes from an x cubed down to a plain x, you put a 0 for the x squared. So, it's going to be coefficients of f of x. You bring down the first term. Bring down the first number. And down here, you are going to multiply, and then we're going to put up here that we're going to add in the box. Way over here, under your constant term, is going to be your remainder. in here. Once we do an example and you look back at it, you're like, ooh, that's what it means. But just right now, just trust me, we're going to talk about it slow as we do an example. Because right now, it just looks like a bunch of math. If you don't know what f of x is, you don't know what I mean by when I'm saying coefficient, so just hang with me. Alright? For an example, if you have something like x cubed plus 4x squared minus 5x plus 44, all divided by x plus 6. You want to divide this using synthetic division. Okay. First of all, we got to know what we're dividing by. So you look at your denominator and you ask yourself, what makes that 0? What makes it 0? Negative 6. So that's what you're going to divide by, is what makes that denominator 0. Now set this up, my f of x is this polynomial on the top. That's what these coefficients are going to go here. And I always write the highest exponent up there, that x cubed. What's the coefficient in front of x cubed? 1. Coefficient in front of x squared is 4. Coefficient in front of plain x is negative 5. Constant term is 44. So that's what I mean by write the coefficients of f of x. We didn't have any missing terms. X cubed, x squared, plain x, no x. So every term was there. Now this is the heart of synthetic division. You always bring the first number straight down. Now we're going to multiply, add, multiply, add, multiply, add. Ready? Everybody okay with the setup? You say negative 6 times 1, and what's that equal to? Negative 6, it goes right there. It's going to be like little check marks. Negative 1 times 6. You're going to multiply